What's the first thing most people notice about a car or a truck? It's the color and paint job. Color is a major factor in the buying process for many customers. Now at Ford, we devote substantial time and creative effort to choosing colors that will meet our customers' needs. Colors to give us a competitive edge. Ford Motor Company paint systems ensure that the best possible paint is applied with a high degree of accuracy. Finish is as important to our paint department as fit is to our body engineers. In recent years, paint material chemistry has been modified to reduce the amount of solvents in paints. This has been necessary to meet government regulations controlling the amount of solvents that can be vented to the atmosphere during the paint application process. This chemistry change inadvertently reduced the resistance of the paint finish to damage from airborne substances. Paint materials that meet the solvent reduction requirements and have improved resistance to environmental damage from airborne substances are presently under development. However, even with improved coatings, some environmental damage will continue to be a concern. In terms of today's coatings, it's especially important for new car dealers to understand, recognize, and repair environmental damage as soon as it's detected. It's also important to take preventative action to protect units in storage. Environmental damage results from airborne substances that fall on the vehicle's horizontal surfaces. Often these substances are dry particles. When these particles combine with moisture and heat, they produce an alkaline solution. This solution, in turn, produces damage, often referred to as water spotting. This is the most common customer complaint. Now, if oxidizing agents, such as organic peroxides, are present, the alkaline solution can become acidic. When this happens, the damage appears as small, irregular, circular spots. It just takes a few hours, and destruction of the paint film, referred to as etching, may show over the entire spot. If this damage is caught early, it can be repaired with buffing and polishing, using readily available commercial preparations. Refinishing is only necessary if the damaging action of these chemicals goes unnoticed for an extended period. You know, dry particles aren't the only cause of environmental damage. Bird droppings, bugs, insects that are smashed on the vehicle's surface, pollen, and tree sap can also cause problems. Before we discuss how various types of environmental damage occur and what you can do to repair it, let's look at the paint systems Ford, and most of its competitors, use today. The vehicle's bare metal surface is layered with 3 or 4 materials: 2 coatings, a primer, and a 1 or 2-part finish coat. The total thickness of all the layers of material is anywhere from 3.6 to 4.2 mils. A mil is equivalent to 1/1000th of an inch. On Ford cars, there are currently 4 layers of materials. In order to clearly illustrate these layers, we have exaggerated their thickness. The bare metal surface of the car is first protected with a coating of phosphate to a thickness of 0.2 mils. Next, 0.7 mils of E-coat is applied. E-coat provides the best protection in the industry against rust and corrosion. The E-coat is followed by 1 mil of a primer to provide a smooth surface for the finish coat. And finally, either a base coat clear coat or 1-part enamel finish is applied. On vehicles finished with a base coat clear coat system, the finish coating thickness is 2.3 mils. On vehicles finished with a non-base coat clear coat, the thickness is 1.7 mils. Currently, trucks are painted in 3 layers. The first layer is phosphate, to the same 0.2 mil thickness as cars. The second layer is E-coat. On trucks, the E-coat layer is 1.2 mils. The finish coat on trucks is 1-part enamel. Its thickness is 1.7 mils. In comparison, the total coating system thickness on passenger cars is either 3.6 or 4.2 mils. The total thickness on trucks is 3.1 mils. OEM finishes must be baked on. So, after the finish coat has been applied, the paint is cured at 265 degrees for approximately 30 minutes as the vehicle moves through a bake oven. These coating systems are incredibly tough, but they're up against some formidable and often unseen airborne substances. You may hear the term acid rain used in connection with the subject of environmental damage to vehicle paint. This is a misleading term. Acid rain does occur, but more commonly, damaging substances arrive on the surface of a vehicle as dry airborne particles. The most damaging of these dry particles are compounds of sulfur and nitrogen. Sulfur and nitrogen are byproducts of industrial combustion. When these substances combine with water or moisture in the air on horizontal surfaces, such as the deck lids and roof, they form sulfuric and nitric acid. It's important to note that even very small concentrations of these acids can cause damage. Over time, the acid destroys the paint film and forms a crater, which etches into the paint and primer layers. If allowed to continue, the acid will migrate between the layers and eventually cause separation, lifting, and cracking. The source of the water that activates the dry, airborne substances may be rain, early morning dew, or water from a lawn sprinkler system. Also, if a vehicle is washed but not thoroughly dried, the water left standing on the surface may join with airborne particles to start the etching process. And in some parts of the country, water used to wash vehicles may itself contain compounds that, if left standing on the surface, may attack the finish. These compounds are most often highly alkaline in nature. And again, results can be water spots or etching. In addition to dry chemical particles, iron particles may also be present in the air and land on the vehicle's surfaces. Iron particles are most often present in the vicinity of steel mills, heavy industry, and railroad lines. For example, the passage of train wheels over the tracks produces small, hot, airborne iron particles that literally embed into paint surfaces on vehicles in transit. Although some of today's OEM automotive finishes are more resistant to these chemicals than others, none are completely immune from damage. Urethane paints are most resistant because their resin system is least likely to react with the chemicals. Metallic colors are more susceptible to chemical action. If the surface of the paint is etched, the aluminum flakes are exposed, and corrosion and discoloration of the aluminum flakes will occur. Although factory-applied baked-on finishes cure almost completely in a very short time, they do continue the last stages of the curing process for up to 30 days. As a result, they may be more susceptible to environmental damage during this time. Be aware that air-dry coatings, such as those applied in a body shop, are also susceptible to attack when the paint is fresh. The longer the paint dries, the more resistant it becomes. In response to the problem of paint damage caused by environmental fallout, Ford Motor Company is currently testing temporary coatings that will protect vehicles from this fallout during transit and storage on the dealer's lot. The transit coating should be removed within 6 months of the vehicle build date. The build date is given on the certification label, located on the driver's side door opening. The transit coating removal operation should be performed indoors or in a shaded, non-windy area to prevent rapid evaporation of the remover solution. This reduces the likelihood of water spotting on the completed vehicle. The removal steps for the transit coating are as follows. Prepare a removal solution by mixing 1 pint of transit coating remover with 1 gallon of water. Pre-wash the entire vehicle to remove accumulated dirt from the coating surface. During hot weather, this will also cool the coated surfaces, so the remover solution won't flash dry. Apply the remover solution with a wash mitt or sponge. Wash the vehicle one section at a time, keeping the remover well lathered while in contact with the coating. Allow the remover solution to remain on the vehicle for at least 1 to 3 minutes to dissolve the coating. Do not allow the remover solution to dry on the vehicle, or the removal procedure will have to be repeated. Continuously agitate the remover solution on the vehicle surface during the 1 to 3 minute removal process to prevent surface drying and spotting. Rinse the vehicle with clean tap water. Use a towel or chamois to wipe the vehicle dry, eliminating water spots. Finally, inspect the vehicle for areas where the transit coating may not have been completely removed. Spot removal can be achieved by reapplying the remover solution, waiting the 1 to 3 minutes, rinsing the solution, followed by wiping with a clean, dry cloth. Whatever the exact causes, the effects of fallout can be seen as dark blotches in the paint, where the pigment in the paint surface has been attacked. Irregular spots that are cracked. Irregular spots that are etched around the edges and dull in the center. Small orange-colored spots, which in this case are caused by iron particles. As we said earlier, organic damage is caused by squashed bugs and insects, bird droppings, tree sap, and pollen. Organic damage is generally easier to identify than chemical damage. If bird droppings, sap, or bugs are seen on the surface, this indicates that damage is taking place. The body fluids of bugs and birds contain high concentrations of formic and tannic acid. It's best to wash these off a vehicle as soon as possible. After washing, if the droppings and bugs have not been totally removed, chemicals could remain and continue to cause damage. If the droppings and bugs can't be removed with normal washing, you should use tar and road oil remover. Damage from organic sources may appear as one of the following: spots that are raised, micro-cracking, or pitting. Bee or bug spots may appear brownish or yellow in color, about 1/8 or 1/4 of an inch in diameter. Tree sap is easily identifiable by clear, raised spots that may be hard or sticky. Pollen deposits are small yellow clusters. As a result of environmental fallout, unsightly spots and cracks may appear on the surfaces of new vehicles after transit and after some time in inventory. If not treated over time, these spots and cracks may result in serious cracking or lifting of the paint. The exact repair of both inorganic and organic environmental damage depends on what caused the damage and how severe the damage is. Let's start with a special case. If iron particles have come to rest on the paint surface, they may become embedded in the paint film. On some light-colored vehicles, tiny dots of rust will appear after some weathering. You can detect these iron particles on any color vehicle by running your fingers lightly over the surface. The particles will feel rough to the touch and will resist removal. The best way to correct the problem of iron particles is by treating the finish with an oxalic acid detergent water wash. Do not wet sand or buff when first attempting to remove the iron particles. This may be required if other approaches don't work, but only as a last resort. The first action you should take is to wash the vehicle. If you still see or feel particles, apply an oxalic acid, such as TST, following the manufacturer's instructions. And for your safety, use gloves, goggles, and protective clothing when applying these products. When applying the solution to the affected surface, it's important to keep it wet. A good way to do this is to soak some strips of cloth in the solution and lay them on the surface. Keep the cloth moist at all times and don't let them dry out. If allowed to dry, paint damage will occur. After a soaking for a while, run your fingers lightly over the surface to see if any particles remain. If the surface feels free of contamination, thoroughly rinse. The rinse should contain baking soda to neutralize the acid. If any particles are left behind, they will produce staining as they oxidize. If some roughness remains, re-soak the surface with oxalic acid and rinse thoroughly a second time, the same way as before. If particles remain after 2 treatments and rinses, it will be necessary to buff and/or wet sand to remove the contamination. Oh, one last caution. All the oxalic acid must be rinsed off all surfaces of the vehicle, not just the painted surfaces. If this acid is left on stainless steel or anodized aluminum, it will corrode them. There are 2 techniques for restoring surfaces damaged by minor environmental chemical contamination: buffing and wet sanding. Wash the vehicle thoroughly with Ford Multi-Purpose Cleaner or an equivalent. Apply a light finishing material, such as 3M's Finesse-It. Apply the compound to a small area at a time so that it can be buffed out while still wet. This results in the best buffing action. Buff off all the spots using speeds in the 17 to 1800 RPM range. Confine your buffing to the spotted areas. Repeat if necessary until all the spots are gone. On curved surfaces and near edges and moldings, buff by hand. Machine buffing could remove more paint film than desirable. Apply polish with a cotton, not synthetic, cloth and rub vigorously until the spots are gone. When buffing is complete, clean off excess finishing material by using a clean cloth and compressed air. Buff out any marks and bring up the gloss using a polisher equipped with a clean, dry lamb's wool polishing pad. If buffing doesn't remove minor chemical damage, the next step is to wet sand using 1500 grit paper. Once again, start by washing the vehicle thoroughly. To properly sand, attach sandpaper to a rubber sanding pad. Use water to lubricate the sandpaper as you sand only the damaged areas. The water is important because it acts as an abrasive as well as a lubricant in this step. To see the progress of your sanding, occasionally squeegee off the water. Sand only enough to remove the damage. If polishing or wet sanding fails to remove minor chemical damage, then refinishing will be required. Minor organic damage can be removed in much the same way as minor chemical damage. Thoroughly wash and degrease the area. Buff to remove spotting or paint swelling. Remove spots and swelling on curved surfaces by hand, and clean off using a clean cloth and compressed air. If buffing is not sufficient, wet sand using 1500 grit paper. If the environmental damage is so severe that it has penetrated the e-coat, stripping and complete refinishing will be necessary. If the e-coat is still in good shape, do not strip it. Refinish OEM single stage or base coat clear coat paint systems using the following procedure. Wash and degrease the area to be painted. Neutralize the affected areas with baking soda and water. Rinse the surface off with plain water. Wash the panel with a mild soapy detergent and dry the panel completely. Sand with 400 grit wet or 320 grit dry sandpaper to get a proper finish. Apply a 2-component urethane primer surfacer. Finish sanding with 600 grit sandpaper. Wash the surface with wax and grease remover. The area is now ready to be refinished. Apply base coat, clear coat, or top coat material following the manufacturer's system. The use of acrylic urethane enamel is highly recommended for this type of repair. Remember, considering the time and effort required to repair environmental damage, an ounce of prevention can really pay off. Wash vehicles regularly and dry them thoroughly. Thorough washing means rubbing as well as spraying, and thorough drying means wiping off all water and residue. It's important to note that both organic and inorganic damage is accelerated by heat. So, during hot weather, vehicles should be washed more often to remove fallout. To avoid the possibility that there are harmful chemicals in the water supply itself, washing with deionized water provides additional protection. Even if deionized water is used, washed vehicles must be dried thoroughly to keep any water left on the surface from interacting with dry, airborne particles that may come along. Now, since bugs are strongly attracted by bright lights, a good preventative measure is to reduce the intensity of lighting used in display and storage areas. In the near future, new paint systems, transit coatings, and paint sealants should make environmental paint damage to new cars and trucks less of a problem. Ford Parts and Service Division will keep you informed regarding these protective measures as they're developed and implemented. Until then, keep your vehicles clean and dry as much as possible. Keep a sharp eye for early signs of damage. Don't let airborne substances spoil the appearances of those great new Ford cars and trucks.